This lecture will cover Chapter 8, Laboratory Testing from Point of Care to Total Automation. Point of care testing is any sort of laboratory test or assay that's performed near the patient. And so this is often considered bedside testing, near patient testing, decentralized testing. In other words, it's away from the actual laboratory and more at the patient's, closer to the patient. So the test is brought to the patient rather than the patient sample being brought to the test analyzer. Point of care testing offers potential major advantages because it can reduce turnaround time for those test results, and that can help to improve the management of the patient's overall outcome. Now, these diagnostic tests are considered essential for some of the following reasons, and that's because it can diagnose a condition to which medication is indicated, it can monitor medication for efficiency or potential toxicity. And so when we talk about something like this, we're talking about things like PT-INR testing that can be done off of a finger stick. So a lot of times, or even something like glucose monitoring, to decide if a patient needs insulin or maybe that they need some kind of glucogen bag or tablets or something like that. So it can monitor the patient at bedside, and you don't have to wait for that sample to go to the lab and be spun down and processed and ran on those analyzers, which can take time. So by doing the testing at bedside, you can get results within a few minutes. There are some advantages to point of care testing, which can include convenience to the patient. Most of the time with point of care testing, most samples can be done off of, or most testing can be done off samples like a finger stick or urine samples, feces. So those are pretty easy to collect. It's not as invasive for the patient. And they do have a faster turnaround time because it is being performed at the patient, and you don't have to wait for that sample to go to the lab and get results back. And it can cause a reduction in length of hospital stays or just the physician's office visit. And a lot of times, a lot of these physician's office, with having the capability of doing point of care testing in the office, this allows them to kind of treat patients without having to send them to the hospital. So point of care testing does improve patient care management because a lot of times, if the physician can avoid sending the patient to the hospital, it usually is a better outcome for the patient because a lot of people don't like to go to the hospital and be exposed to additional things or run up bills and things like that. So if they're able to treat without that hospital visit, that's always a good thing. And most of the equipment's fairly easy to operate. Now there are costs associated with point of care testing. And that would include training and maintenance of the machines, keeping up that competency, any sort of labor costs associated with processing and analyzing those samples, and maintaining that equipment, doing those checks. Just like any testing within the lab, point of care testing does require to go through quality control, making sure that any kind of analyzer that may be associated with it, that you keep up with the regulations and what they state for those particular analyzers. And of course, also there's cost associated with getting the licensure to actually perform the testing in your laboratory, your physician's office practice, or wherever you may be setting up any sort of point of care testing. And so there are costs associated with that licensure. And you are kind of billed based on the amount of tests that you perform and the complexity of those tests. And so also part of those the regulations does state that you have to have some sort of proficiency testing program. And so you do have a cost of those proficiency testing programs. And this is just kind of that report card check where you get samples with unknown values that are known to the company, but they're unknown to you, and you run them just like a patient, send in those results, and essentially you get a report card back that kind of compares you to what other laboratories get for those results, as well as how close you are to what the known value was. Now, just like any test that's done in the lab, any test done outside of the lab also has to have a quality control program available, and it's usually based off of what the manufacturer for that particular uh, test kit or analyzer says for that particular analyte. And so all sites performing any sort of laboratory testing are regulated by CLIA, and they must be licensed in order to perform any testing. And so CLIA has granted deemed status to approve accreditation organizations and allow these entities to accredit and license testing sites. So in other words, there are other organizations outside of CLIA that will also do inspections and kind of set the rules. But CLIA is the base of all of those rules. So state governments, state agencies, any kind of city agencies and governments can also state what sort of requirements must be included within your laboratory, which can include things like the qualifications of personnel that are performing the tests. And now, while these regulations can be more stringent than what CLIA states, they cannot go below what CLIA states. Just like any test, point of care testing is also categorized based on some various factors that are regulated by the FDA. And so this site here would actually take you to the FDA site that shows the different criteria that go into categorizing these tests. And so that criteria can be based on anything like testing personnel requirements as far as what sort of education they might need to perform the test, the reagents within the kit, the actual procedure itself. So there are a lot of factors that kind of go into it, and they kind of evaluate the risk for error. And so based off of the criteria that goes in there, it gets a score, and based off the score will depend on what sort of category that those tests are categorized into. And so the different categories include waived testing, which means that the regulations for it are a little less stringent, and this is usually considered testing that could be done at home. So some examples of waived tests would be like a home pregnancy test or the COVID testing, things like that. Some of your diabetic strip testing, glucose monitors. And so what you can actually do is go on FDA site, and you can see down here at the bottom or an example of the FDA site, which shows the categorization of different tests. So you would input the test that you're looking for. So this is an example of an HCG test. And so there are a couple of test kits that are considered moderate complexity, and then there are also several up under that that are waived. Now there are pages and pages you can see of this actual testing here, but because there are a lot of HCG or pregnancy tests out there. Now moderate complexity tests do have more requirements with QC and educational requirements, personnel requirements. High complexity test, the main difference between the moderate and the high complexity test has to do with the educational requirements that is involved, and then there are some other, a few other things that are involved that kind of differentiate those as far as quality control and things, but most of it for the high complexity testing is going to be the education. So you need more specialized education and training to perform some of those high complexity tests. So moderate complexity testing is usually, most of it's just putting the samples on the analyzer and running it, whereas high complexity testing would be things like microscopic work or identifying bacteria, blood bank testing, things like that. Provider performed microscopy is when the provider, the physician, physician's assistant, nurse practitioner, when they actually do the microscopy to report out on that patient. So this would be something like a physician's office might do a wet mount on a female patient looking for any sort of yeast or bacteria or things like clue cells or a trichomonas, any sort of sexually transmitted issues that could be present in that sample. And so the physician actually does that microscopy. Some other things that they could potentially do, provider performed microscopy on, would be stuff like a urine sample, skin scrapings, things like that. Now, just because a site is performing waived testing does not mean that they don't have to do any of the regulations or anything like that. So any site that is doing any sort of testing, whether it's waived, provider performed microscopy, moderate or high complexity, they do have to have a certificate of licensure. And this has to go through the state, through CLIA. And so if a site is just doing wave testing, then they would get a certificate for just a certificate of waiver. And then, of course, they have to adhere to all of the rules and regulations that are set by CLIA or those state standards. And then they also have to make sure that they are performing the test just as the manufacturer states. And so all laboratory testing must meet the same quality standards regardless of where it's performed at. So if it's done in the lab or if it's done at bedside, those things still have to be met as far as those quality standards and meeting the requirements of those procedures that the manufacturer states. Now for moderate complexity testing, that's considered in a point of care setting, there can be some additional requirements that are a little bit above what the waived testing requirements are. And this would include things like instrument validation, quality control, any sort of method validations or anything like that that are required for typical moderate complexity testing. Now, example of this, a moderate complexity point of care test would be an iStat analyzer. So these are handheld analyzers that are issued by Abbott Laboratories. And these analyzers will do a variety of tests on it, just depending on the cartridge that comes with that analyzer or the cartridges that you order. So you could do a basic metabolic panel with some chemistry tests, hemoglobin hematocrit. There are cassettes for the iStat for things like your clotting testing and cardiac markers, things like that. And so that analyzer does require a little bit more things that have to be done as far as quality control standards and things like that. Ultimately, CLIA does set the regulations for what you have to do and the requirements that you have to meet for your particular laboratory setting. Based off of the type of certificate you have. So if you have just a certificate of waiver, they do state what kind of personnel you must have on staff. Now, with any of these, you must always have at least a laboratory director, and that's usually the doctor that's gonna oversee that laboratory or that office. And then you have to have something like a technical consultant to kind of help you with the regulations for that. So the laboratory director or the physician can oversee all of the categories within those requirements. However, it does have to be stated in your procedure exactly who is going to serve what role. Now, CLIA will set the standards for inspection for your various laboratories, regardless of what they are. Now, provider performs microscopy only as well as waived testing are typically not going to be inspected by CLIA or any other kind of accreditation agency unless there's some kind of complaint issue. So if there was a complaint issue to the state, any kind of suspicion that there's any kind of fraud going on or any kind of illegal activity, if a laboratory, maybe if the state gets wind that they're performing testing and they don't have a valid certificate. So these are the kinds of things that could initiate any sort of inspection. But regardless of what sort of certificate you have, CLIA does state that you must have written policies and procedures in place And those things, the things that must be included in that procedure are things like the patient preparation, sample collection and preservation. So how long can you store that sample? How long is it good for? Instrument calibration, if it's required for that machine, any sort of QC that is required, along with any sort of remedial action. What do you do if QC fails? And in most cases, you're not going to run testing, you're going to probably send it out. Or it could go through a checklist of things like repeat in QC, try this, recalibrate the analyzer. So it could just have a process of what you should do if QC fails. Any kind of equipment performance evaluations, any kind of maintenance checks, temperature checks, things like that. How to actually do the test and what you're going to do as far as reporting the test and recording those results, or how you report and interpret the test. So these are things that they do require that you have in the procedure. While you can refer to manufacturer procedures, they're not your overall procedure. You must have something set up for your laboratory specifically. The greatest source of error that we usually see is going to be anything that's in the pre-analytical error. So this is usually going to be something like how the sample's collected, how it's stored, how it's transported, things like identifying the patient incorrectly, mislabeling samples, things like that. So patient-centric testing is basically going to be where you take the testing outside of the healthcare setting and you put it into the hands of the patient so that they're able to kind of help monitor their health, and kind of be proactive to prevent any sort of issues down the road, or in any sort of basically to kind of prevent any sort of emergency from happening. So good examples of this would be glucose monitoring. So patients that are diabetic, they have the glucose monitors or the various wearable meters that are out there and available now, so that the patient can kind of keep check of those glucose levels, adjust medications as needed. And so there are a lot of different emerging technologies that are helping to kind of make a more patient-centric testing platform. And so another example of this would be how COVID testing has kind of come out to be available to the patients, so that patients can check for COVID from home, and not have to go out into the public and potentially transmit that disease to someone else. Now, personal direct to customer genetic testing is something else that's kind of been emerging over the past several years. And so this is where you can buy the DNA test kits and then collect a sample, a cheek swab, and then send those back in to be tested. There are a lot of other patient direct to the consumer testing methods out there. There are different things like where patients can provide a finger prick and submit a little bit of a blood sample onto a filter paper, and various tests that can be done with that. Different fecal blood tests where you can collect a fecal sample to send in to do different genetic testing, or DNA type testing that's looking for certain markers to detect colorectal cancer. So there are options that are kind of starting to emerge a little bit more to kind of do some diagnosis and looking for various diseases. Your non-instrument based point of care testing are usually very low cost testing procedures. These would include things like your pregnancy test, fecal occult blood, infectious mononucleosis. So these would be like your serology, antigen, antibody type reactions, or for example, with your pregnancy test, you've got a line that is embedded or impregnated inside that little paper, and as the urine flows across it, it's doing that antigen antibody complex reaction where it is tagging that hormone. It's complexing it with something else. It's got a color dye that's in there, and so as those things start to kind of come together on that little paper, as the urine flows across it and it catches those hormones, it gets caught up in there and it starts attaching, then you get the presence of that visible line from that antigen antibody complex. And so these non-automated tests, it's a lot of test kits and things like that. The COVID test that most of us have probably used. These are all example of the non-instrument based point of care testing. And they're usually, the sample for it is really easy to collect. Sometimes you can use whole blood from a venal puncture or a finger stick. Could be urine, feces, saliva, throat swabs, checking for strep. So these are non-instrument based. Your handheld point of care testing devices would include something like glucose meters, the iStat meter that I mentioned earlier. There's things like A1C meters that test for the presence of the blood glucose over a length of time, a 3-month period. With these machines, these point of care analyzers, most of them do have some sort of built-in QC within the machine, especially like your blood glucose machines that most people have at home. It goes through checks every time that you turn it on. There's a lot of barcode technology involved. Your test strips may have some sort of computer chip on them. Your test cartridges for something like the iStat, whenever you go to perform that test, it does have barcode technology, so you actually scan the barcode of the patient to put the patient information into the analyzer. You scan the barcode of the test kit. If you were to run controls on it, you have the capability of scanning those as well. The cartridges themselves that are used with these various handheld analyzers usually have some sort of computer chip in it or barcode or something on the cartridge itself so that it helps identify what the test is that you're about to perform. Depending on the test method, it can be costly, but it can also save money as well. And generally, these are used more for screening processes. If anything is kind of considered critical, anything like that, let's just say you had a iStat performed and it showed that the patient had a hemoglobin of 6. That might be something that you would verify by actually sticking the patient, getting a venal puncture stick and sending that to the laboratory to be verified. And in the meantime, you could go ahead and start working with that patient as far as options for treatment should those results come back and confirm that hemoglobin result. And these analyzers also have the capability of being, most of them being connected to some sort of LIS or laboratory information system to transmit those results so that they are stored directly into the patient chart. Now, like I just previously mentioned, these cartridges and things for these analyzers can get pretty costly per test, so you don't want to waste anything. You want to be sure that you properly maintain that machine as far as the maintenance that's required on those machines. And because they are point of care type test machines, you can do this testing at bedside. So you want to use caution to make sure you don't do any sort of errors. You don't have errors by doing things like reusing test cartridges. If you think about the fact that a glucose test monitor, if you got blood on that machine and you accidentally touched that blood to your patient after you've pricked their finger, then you could introduce someone else's blood to that patient. Reusing test strips, that could introduce blood from another patient to the second patient. So you want to be very aware that you can cross-contaminate things, so you want to keep your machine properly maintained. We do live in an age where we rely a lot on technology, and part of that would be the informatics, so the computer system, the programs for actually resulting lab results. And that's going to include things like your LIMS, your Laboratory Information Management System, and your LIS, Laboratory Information System. So your laboratory information management system represents a sample-centric information. So this is basically labeling it, ordering it, those things like that that kind of center around the sample itself. Whereas your LIS is the laboratory data. So running the test, getting those results transmitted back to the patient's chart. And so there are a lot of operations that are involved in this, a lot of different software coding that's involved to make sure that all of this stuff communicates. And so the middleware is the software that kind of connects these software components and application in between things like the instruments to the laboratory information system to the overall electronic health medical records to get those results back to the physician's office or into the patient's chart in the hospital. Now, most of your healthcare settings now have some sort of IT personnel. Somebody's going to be involved in making sure that those computer functions, that technology is integrated properly, that there's validations performed, that what you put in is what you get out. And what all of this does is it allows the provider to put the orders in, and then those orders can get transmitted to the laboratory somehow, some way. These systems can also have a way to allow you to monitor those results. There's a lot of features that are kind of built in them that help to give quality checks and monitoring those laboratory results, even down to monitoring your quality control and being able to see that within your laboratory information system. And so they also will be involved in interfacing. So your analyzer, once it's done running those tests, the interface will allow it to communicate to your laboratory information system, which will also communicate those results to the healthcare electronic medical record. The computer applications has helped to prove things like pre-analytical functions. This is the before you examine the sample. And so by using computer systems, you're able to enter the order into the computer system. Everything's kind of tracked. You're able to sometimes print requisitions, print any sort of collection labels, things like that. So it takes away from handwriting. It helps with patient identification, and it kind of just improves the whole workflow. Your analytical phase is when you actually examine the sample. So being able to have any sort of computer application involved in that allows for that barcode tracking again so that the analyzer can read it. You can also do things like set up programs within your computer system where if the results fall within this category, if they're within these values or within this range, then you can go ahead and send these results out to the electronic health record. And so this is called auto verification, where if the results are considered normal or just barely outside of normal, not critical, then you would go ahead and send those results out. The computer system would do it for you so that you don't have to worry about reviewing those results. Your post-analytical phase is going to be after the examination. So this is actually transmitting those results to the proper place. So this could be faxed results, it could be going to the computer, it could be sending out critical results to various pagers and notifying those doctors of those results if there are critical values. Automation does help to reduce any sort of medical errors, especially when you have barcodes involved. It reduces the specimen sample volume, so by automation, we're able to use a less sample volume to run multiple tests. It increases accuracy and precision, and it improves patient safety as far as for the laboratory staff, because there's a less exposure to that sample with putting it on the analyzer. Then you're not being exposed to that sample as much by actually performing manual testing. It increases the turnaround time, so from collection to results, that time that it takes, it increases that time because of the automation. And it partially alleviates the impending shortage of skilled laboratory staff. So one staff member can place the samples onto the analyzer to be run rather than taking up that time to actually um, perform those tests, which alleviates that staff from focusing on just one test at a time, and they're able to do multiple things while those samples are running on the automated analyzer. Now, as you go more through your courses, you will become more familiar with the whole automation process, but that automation process will include things like some sort of way for that sample to be siphoned up and tested. So there's some sort of pipette or something inside that analyzer. And then it's going to also be able to measure that sample volume and add that to reagents. So there's usually some sort of reaction wheels. Depending on what the test is, it may have to put the sample with a particular reagent, and then it incubates in that analyzer, and then that moves to another reagent. Maybe it's looking for a color complex. And so all of this is kind of built into the machine. A lot of them use things such as a photometric technology, which has previously been discussed, to quantitate the extent of the reaction. So when we talk about quantitate, there's an N in there, which means it's going to give you a number value. And then, of course, it's got some way to record and release that data based on different values that are set within that analyzer. And of course, the steps involved will mimic what you would have done if you were doing that test manually. So let's just say, for example, if you were running a glucose test, typically you would collect the sample, you would take that patient's sample, you'd process it by mixing it with some sort of reagent or some sort of incubation step, and then once you've done that, based off the procedure, whatever particular chemical reaction you're doing, then you'll actually put it onto, let's say, your spectrophotometer. You would do those measurements, you would do that plotting based off of those results that you've got or that calibration curve that you had already made. And then you would input that data into your equations, and you would figure out ultimately what that result is. Over the years, we've seen more automation come out into the laboratory. So there are a lot of tests out there that up until a few years ago were still performed manually, and then automation has been developed. So some of these tests are transitioning away from manual testing to more automated platforms. And this allows for versatility and flexibility. It allows you to take a higher volume of those test orders in, which speeds up the whole testing process, which ultimately in the end is better for the patient because you can get results out a little bit quicker. Initially, these automated systems were introduced to your larger high volume laboratories like your chemistry and hematology departments, but now we're seeing more automation into the other departments that are kind of growing, like urinalysis. Up until several years ago, urinalysis microscopics were always done with a tech looking at the microscope, but over the years they've developed new technologies that is able to take pictures of those cells and kind of categorize them for urinalysis so that the microscopic is actually done through automation now, and it allows the tech to review those images and make sure that they're categorized properly. Microbiology and blood bank, still a lot of manual testing done in these areas, but there is a lot of automation coming into both of those areas now. And you'll get to hopefully see some of this once you actually get into your laboratory settings.